All right, kids, we are on page 3 of your graphing and solving root equations test review. It's the application problems, which are the most fun. So the first one is a profit equation. So a company determines that the price P of a product, or it's a price equation, I guess, not profit, can be modeled by the function P of x equals 70 minus the square root of 0.02x plus 1, where x is the number of units of the product demanded per day. So x is the number of units of product that are demanded per day, and P is the price of the product with that demand. So the demand of the product controls the price. The first thing they want us to do is find the price of the product if 100 units are demanded per day, and then round to the 100th, and we'll talk about why we're going to do that. So A, they're telling us, so we know P of x is equal to 70 minus the square root of 0.02x plus 1. And they told us for part A that the price of the product is $100. Oh no, we're finding the price. They told us that we are selling or demanding 100 units per day. So for this, x is equal to 100. So we are finding P of 100. And what that says is I'm going to plug 100 in and see what number I get. So that's equal to 70 minus the square root of 0.02 times 100 plus 1. That is hard to see. All right. So P of 100 is equal to 70 minus, and this is the square root of 0.02 times 100 is 2, so 2 plus 1. And so that's just 70 minus the square root of 3. Now this is an application problem. We expect a real answer. You don't want to tell me 70 minus the square root of 3 dollars. So we're going to go ahead and use a calculator to work that out, and when you do, you get 68.2679. Now it told me to round to the 100th, and the reason it told me to round to the 100th was that I was finding the price of a product. And so I need dollars and 2 decimal places, which is our cents, right? So this ends up being 68.27. And what that tells us, guys, and we're going to go ahead and just write, it didn't tell us to write a sentence, we're going to write a sentence, just so that we really understand what we figured out here, is that when 100 products are demanded, the price per product is $68.27. So when we have a demand of 100 products, our price is $68.27. And so this is something that businesses actually do. It's a supply and demand relationship, right? And so when demand is in a certain place, they will sometimes drop the price. The more the demand, the lower the price, and the less the demand, the higher the price. All right, so part B, it says find the number of units demanded if the price is projected at $21. So if our price per unit is going to be $21, which is significantly different from this price that we found for part A, how many units are going to be demanded? What is the demand that causes that price? And so for this one, they gave us the price. P is equal to 21. So what we do is we say, okay, 21 equals 70 minus the square root of 0.02x plus 1. And so now we're solving a square root equation. For the first one, we were just evaluating, right? And now we're actually solving. And so I need to get the square root alone, right? We can rewrite this. What's under the square root is the 0.02x plus 1. We can rewrite it with an exponent of 1/2. This is 70 minus parentheses 0.02x plus 1 to the 1/2 power. We can rewrite that. And then we're going to move the 70 because it's in our way. And when we do that, we get negative 49 is equal to negative 0.02x plus 1 to the 1/2 power. Those parentheses are still not alone. That negative right there needs to go away, and so I divide by negative 1. And so I get 49 is equal to 0.02x plus 1 to the 1/2 power. And to get rid of that 1/2 power, we're going to square both sides. And remember, this 1/2 and the 2, they cancel each other out. And so we get 49 squared, which is 2,401, is equal to 0.02x plus 1. And then we are not done. We need to solve that equation. And so I subtract the 1 from both sides. I get 2,400 is equal to 0.02x. And then I divide both sides by 0.02. And when you do that, you get x is equal to 120,000. And so if there is a demand for 120,000 products, then the cost will fall to $21 a product because there's so much demand that we don't have to charge as much for those products. But when there's not much demand, we have to charge more so that we can make the money we want to make. All right, guys, part C. They ask, what happens if the price is increased to $80? So again, they've given us price, like they did here. And so what we're doing is we're solving the same equation that we had in part B, but instead of P being 21, P is equal to 80. And so this is 80 is equal to 70 minus the square root of 0.02x plus 1. And you solve that equation, subtract 70. You get 10 is equal to negative square root of 0.02x plus 1. And guys, I left the square root on this one. I didn't write it in parentheses with 1/2, but it means the same thing. It means exactly the same thing. Now, guys, here's the thing. Over here, we were able to get rid of this negative right there, that negative. I was able to divide that negative away. And here, when I divide this negative, I get negative 10 is equal to the square root of 0.02x plus 1. And remember that our square roots are not supposed to be negative. We're functioning in the real world, and in the real world we don't have negative square roots. We only have positive square roots. So I have a square root is equal to negative 10. And when that happens, that means that this is not a possible solution. It means that that doesn't work, okay? And so what we say is we say no solution. Now, what does that actually mean for this problem? What does it actually mean for this problem? And so to answer that, we look back at the original equation that was given, 70 minus the square root of 0.02x plus 1. And guys, this is a square root function that has had several transformations happen to it. We've got this weird horizontal compression going on, and that is something we haven't talked about a lot, but it's there. We've got a horizontal shift, not 1 unit because of the compression, it acts weird. But we also, most importantly, have a reflection over the x-axis. And we also have this movement up 70. And remember that our parent function, the parent function domain, and so I'm going to write that down, don't get confused, y equals the square root of x, that the domain is 0 to infinity and the range is 0 to infinity. And remember that a reflection reflects our range. The range becomes negative infinity to 0. Well, for p of x, the range is reflected. The range is negative infinity to our vertical shift, and our vertical shift is 70. And what that tells me is that they cannot charge over $70 for those products. They do not charge over $70 for those products. So the price of those products cannot get above $70. If they sold one product, it would be under $70. That's our max price. And so there is no way that we could sell these products for $80. And again, the way I know that is because when I get to this place right here, I have negative 10 is equal to a square root, which is not something we work with this unit, okay? And also because of the range, because I know that we have been reflected, which is that negative right there, and I know we've been shifted up 70 because of that 70 right there. So I know my range is negative infinity to 70. I know I've got a maximum of a price of $70. If you tried to look at this in your calculator, you would also see that 80 is just not a feasible price for this situation. 80 doesn't work. All right, guys, let's move on to number 10, which is actually significantly less confusing, despite the fact that it is a formula with a decimal in it. It's the formula for the side length of a regular octagon. And so remember, octagon, 8 sides, like an octopus, right? It has 8 arms. The formula for the side length is equal to the square root of the area over 4.828. So we're going to find the side length of an octagon that has an area of approximately 1,743 centimeters squared. And so, side length is equal to the square root of area over 4.828. And they gave me the area. A equals 1,743. Remember that you're going to do this in the calculator, but that I still need to see you plug in that number, 1,743 over 4.828. And I know you're going to throw it into the calculator because I had to as well, but I want to see this. I want to see that, okay? And so when we put it into the calculator, we get 19.0005014, and in this case, it's okay for us to say 19. We do want some units because there are 3 zeros there, y'all. That's why. We don't round if it's like 19.5, don't round. But there are 3 zeros there, so it's okay to do that. Area was in centimeters squared, so my side length is going to be centimeters. And then part B says find the area of the octagon that has a side length of 1 foot. So again, S equals the square root of A over 4.828. And in this case, they gave us S equals 1. Don't be confused by that. It's a super easy equation to solve. So 1 is equal to the square root of A over 4.828. And then this is a square root equation. We look at what's under the square root. It's an A divided by 4.828. I can rewrite that in parentheses if we want to. So A over 4.828 to the 1/2 power. And the parentheses are alone, so I square both sides. And I'm going to get rid of that 1/2 right there. So 1 is equal to A over 4.828. And, how do you get rid of something in the bottom of a fraction? You multiply. So this is 4.828. I'm going to multiply both sides by 4.828. And 4.828 times 1 is 4.828. And that's equal to your area. We're done. Those two cancel out, and we're done. Now again, we want units. In this case, they gave us the units in feet. So my area is 4.828 feet squared. And that's our answer. Good to go. All right, kidlets, please, when you're doing this, make sure that your answers look like my answers, that you've written all the work, okay? Make sure when you're doing these application problems that even if you're just plugging in numbers that you show me the plugin. So like here, I want to see it. And up here as well, I understand that you may just throw this piece right here into the calculator, but write this on your paper so that I know that you know that that's what you're doing. All right, kiddos, I'll be here tomorrow morning if you've got extra questions. And remember, the test is tomorrow.